So this is group 10 and we worked on a Morse code translator.
So this is our EC311 project demo. Starting off, we have the on-off switches. The far right, this corresponds to the on-off for the 7-second display. So if I switch this from off to on, notice the decimal over here turned red. That's how you know the 7-second display is on. Now if I hit the switch the second farthest from the right, hit switch. Notice that the far left green LED goes on. That's how you know that the VGA is on and will start displaying stuff. So our buttons, far left, this button right here, this corresponds to dot. So if I hit dot, that corresponds to the letter E. And the 7-second display will change instantly so that you know where you are on, say, Morse code tree. If I hit send, we get the letter E on our VGA that we made ourselves. And then you can reset by hitting this top button right here. So if I hit reset, notice the 7-second display goes blank, the VGA goes blank, and we're starting from the beginning. Now this middle button here is the dash. So I hit dash, 7-second display turns into T, I hit send, we get T on our VGA. Now for the 7-second display, this is the only way we can display T, though it's the lowercase t versus the uppercase T for our VGA. And you don't have to reset after every input. So right now I'm at T. If I hit dot send, you get the letter E on the VGA, you get the letter E on the 7-second display. So we also included multiple numbers. So for example, we included the number 1. So if I do dot, dash, 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 we get the number 1. And we of course included all 26 letters, all 10 single-digit numbers. So just an example of a more advanced letter, if I do dash, dot, dash, dot, we get the letter C. Now in addition to letters and numbers, we included anything that the International Telecommunications Union suggests being used in standard Morse code. So that includes a bunch of symbols. For example, if I do dot, dash, dash, dot, dash, dot, hit send, we get the @ sign. This is one of the many punctuation and symbols that the ITU uses in Morse code. Now, unfortunately, there's no 7-second display for this, so we couldn't include it. But there are a bunch of values that just don't correspond to letters or numbers or symbols in English Morse code. So if I do dot, dash, dash, dot, dash, I hit send, we get an error sign, because in English this doesn't correspond to anything. So hit reset again. We also get the error sign if we input more than 6 inputs, because there's only a max of 6 in English. So if I just put a bunch of stuff in here, whatever that is, we get an error sign. And finally, just in case you're curious, these bottom 6 LEDs here, these correspond to a 6-bit binary number that we assigned all of our letters, numbers, and symbols to. This was just more so for our decoding and coding purposes. However, we kept it in, and we just wanted to let you know what this was in case you're curious. So this won't mean anything to someone who didn't do the coding. And yeah, thank you.
So this is our top module. We basically take all our inputs. We have input for clock, we have input for each of the 4 buttons that the user can press. And we also have 2 inputs for the switches that toggle on and off the displays. And these are just outputs for each of the displays. And in our module, we call upon the debouncers for each of the buttons. And then we send those clean button signals into our getCode module, which will output a code and a temp letter. Temp letter is used in our converter module for the 7-second display, and code is sent to the VGA module, which will just display the actual character on the screen upon hitting send. So this is our debouncer module. We're basically using a counter which increments when the user holds the button down, and once it reaches a certain value, then it will trigger the clean button signal to be on.
This is our getCode module. Our getCode module has 5 inputs, the four buttons, dot, dash, send, reset, as well as the clock. And it's 2 outputs, code, which corresponds to our VGA display, and temp letter, which corresponds to the output on the 7-segment display. We start by having these parameters, which just makes it easier to code the case statements by having all of the 6-bit numbers just correspond to like one thing to enter. And these parameters down here are for the empty states, whereas for example, trying to get to the number 2 or the question mark requires a state that we need the values before it to be stored, but we don't actually want anything to display on the screen. We start by having an always block, which depends on the clock, so this is always running, and this temp letter is current letter. And segment, we have how we get the 7-segment display to be the live value that the user has entered by pressing the buttons. Then this dot is how we start assigning the code, where if a dot is pressed, they go through a case statement, or whichever letter you're currently at. If a dot was pressed from that letter, we assign the current letter to that value. And then at the end, after the case statement has run, if none of the values that we expected to happen, the default is that we'll display our error screen, and then the current letter will be assigned to letter, which is how, in the end, when our send statement is set, the code is assigned to the letter. So only when the send button is pressed does the VGA change, whereas the 7-segment display is a live update of what happens. And then as you can see, our dash is formatted in a very similar way to a dot, where it's a case statement, and each depends on where you're at, depends on where you're going if a dash was selected. And lastly, our reset button, where if this button is pressed, wherever you're at, the screen will turn to our 111, which is just our blank, and the current letter is also assigned to our blank, which is our initial start statement, and then we just set the letter at the current letter. So the same thing is displayed. So everything is reset to its beginning state.
Our converter module for the 7-segment display, the input on-off is for the FPGA board, which switches our project from the VGA display screen to the 7-segment display. And here we are just converting the 6-bit binary for each of the letters and numbers into a 7-bit binary, so that way we can display to the screen. And 1 is a off here, and 0 is on for the individual segment. And here's all the conversions. And then here in our constraint file, we have the segments just going through the individual bits of the 7 bits. This is our decimal point to show that we are in 7-segment display mode. And here's our digits, which is only having the rightmost position on right now. To prevent confusion of what's being displayed, such as O and 0 and 9 and Q, we have used the 7-segment set code alphabet.
These are our VGA files. We start with putting our clock and reset into a clock divider to get a slower clock. This new clock we put into the VGA controller along with the 6-bit letter you saw in get code and the reset button. This will output HSync and VSync, which are used to set the VGA so that we don't get weird things appearing off screen, etc. We set some parameters here for ourselves, and we set the width position and height position. And these are used in these inequalities down here, making the letters. So we have 6 boxes in bounds A through F, and we use these and arrange them in a way to create each letter, number, and symbol that we wanted. So the letter A is 2 vertical lines and 2 horizontal lines, which you can see here. And these inequalities with width position are used to set which LEDs should appear on. Then if we ever don't use one of the boxes, we just set all these to 0 so they don't appear. Then some took all 6, others only took 5. And we used whichever ones we needed. We set ourselves to 6 boxes because anything more than that became very, very hard to manage, and it was already somewhat difficult to manage. Since we made all of these ourselves, we didn't use an outside library. We included the accented letter E, since that's included in International Morse code. And then we set all the temporary 6-bit numbers that you saw in get code, along with the error 6-bit number, to this error symbol that you see right here. And then at default, we just don't want anything to appear, so we set them all to 0. We then set the inbounds to their respective wires, A through F. These wires are put into this logic statement, where if it's any of these wires, put the LED on, otherwise the LED is off. And this LED on variable is outputted from the VGA controller and is used in this statement here. So VGA on, which is also inputted, that's that switch you saw earlier. If this is on, then if LED on, we want the RGB value on that pixel. And this lets us, we don't want to deal with color, so we just set all the RGB to 1. Otherwise, set them to 0, and this gives us those letters and symbols that you saw earlier.